Good evening, students. In the last class, we have seen about the architecture of 8051. Architecture of 8051. We have just started with microcontroller. So let me brush up with those things and then go ahead with the memory. So we have a general purpose computer that we are using in a day-to-day life, a laptop or a desktop, whatever. And special purpose computer also that we are using, that is mobile phones and other dedicated special purpose processors also that we are using. Those are starting from micro ovens till your washing machines. They are dedicated for special purposes. They are programmed for special purposes, and for those special purpose, whichever computer or processor that we are using, it can be termed as microcontroller or microprocessor. So what is the difference between microcontroller and microprocessor? I have said already. So microprocessor is nothing but a central processing unit. In the central processing unit, we will be having an ALU, arithmetic logic unit, and program counter, stack pointer and other registers, and timing circuits, interrupt circuits. This and all you will be having in the central processing unit. And memory will be added externally to the microprocessor. Memory will be added externally to the microprocessor. The memory may be of ROM and RAM. Memory may be of ROM and RAM. And other than that, input output devices will be connecting externally. So for a microprocessor, you have a CPU. CPU is nothing but ALU, registers, timing circuits and interrupt circuits. Okay. So the registers are of a stack pointer register, program counter register. So program counter register is a 16-bit register. It is used for holding the address of the next instruction in sequence, whichever instruction that is being stored in the memory. And stack pointer is again an 8-bit register. It is used for pointing out the stack memory. So microprocessor, you will be having a central processing unit, which will be having a memory, which you will be connecting externally a memory and an IO device. If IO device, memory and the central processing unit all together or manufactured on a single chip or implemented or manufactured on a single chip, that is said to be a microcontroller. So in your syllabus you are having 8051 microcontroller. About 8051 microcontroller, it is an 8-bit microcontroller. 8-bit microcontroller in the sense it is going to process 8 bits of data at a time. Bit is nothing but either 0 or 1 is said to be a bit. Nibble is nothing but combination of 4 bits is said to be a nibble. Combination of 8 bits is said to be a byte. Okay. So what are the special features of 8051, or what are the distinguished feature of 8051 as? It will be having internal ROM and RAM. As such, a microcontroller will be having internal ROM and RAM. Similarly, this 8051 microcontroller is also having internal ROM and RAM, input output ports, timer and counters, and serial data communications. Let me brush up with the architecture of 8051. You have input output ports. Okay, you have you have a serial port communication. For serial port communication, you have two pins, TXG pin and RXG pin, one for transmission and another for reception. Okay. And then crystal oscillator pin for providing the clock signals. All the operation of the microcontroller will be synchronized by the clock. Okay. Right. Then you have totally will be having two external interrupts. We have two timers, timer 0 and timer 1, and inbuilt hardware is for RAM is you will be having 128 bytes of RAM. You have 128 bytes of RAM and 4K ROM. Okay, you have two timer registers, timer 0 and timer 1 for counting and the timer operations, and the interrupt, you have two external interrupt and three internal interrupts. Okay, altogether you will be having 5 interrupts. Okay, INT 0, INT 1 are said to be interrupts, external interrupts are said to be external interrupts. Okay, so regarding a bus, bus is used for carrying data. Bus is nothing but group of wire which is used for carrying data or address. So for carrying the data we need data bus, for carrying the address we need the address bus. So as 8051, it's an 8-bit microcontroller. So we will be having 8-bit data bus, and each line of the memory will be addressed by 16-bit. With each line of the memory will be addressed by 16-bit. Hence, we will be using 16-bit address line. 16-bit address line. Okay. Right. Other than that, in the CPU we will be having registers. What are all the registers we will be having? Register A and B. Register A is nothing but accumulator, and a 16-bit program counter. It is used for storing the address of the next instruction in sequence, and the data pointer register is also used for carrying the address of the memory. And you have an 8-bit program status word. Which is otherwise said to be PSW. That is all available in the CPU. Okay, in the CPU. So 8-bit program status word used for storing the status of the program. For example, if you are adding two numbers, if you have a carry or if you have an auxiliary carry, or if the result is having even number of ones or odd number of ones, that will be represented by the parity bit. Those status will always be reflected in the program status word register. It is an 8-bit register. And a stack pointer is used for pointing out the scratch pad RAM or the general purpose RAM of the stack. So internal ROM is of 4K in 8051. Internal RAM is of 128 bytes. It is of 128 bytes. Okay, 128 bytes. 128 bytes. And 8 bytes of general purpose data memory. Okay, 8 bytes of general purpose data memory, and 16 bytes of individual bit addressable memory, that we will see while we are dealing with memory separately. And we have 4 ports from P0 to P3. Each port is an input output port, and each port is having 8 bits. Totally we will be having 4 8-bit ports, and 2 timer or counter register, that is of 16-bit T0 and T1. And for serial data communication, and we will be having one register that is said to be SBUF, serial buffer. So that is used as a full duplex communication. Okay. Control register, we will be having timer control register, timer mod register. Okay, and serial control register, program control register, interrupt priority, and interrupt enable. These are the control registers that we will deal when we are dealing each of them separately, namely your interrupt, timer, and your serial communications. While we are dealing this separately, we will be seeing those registers, what are all the registers involved with each one, namely your timer, your serial communication, and the interrupt. We will see it separately. And 2 external and 3 internal interrupt sources. Okay, and you have a clock circuit, right. So now this is regarding your architecture of 8051. This is regarding your architecture of 8051. Individually we will see, and we will see in detail everything. Okay, the internal RAM, as I said already, will be having 4 register banks and 16 bytes of bit addressable memory, and 8 bytes of general purpose data memory. And coming to the pin diagram, it is a 40 pin IC. It's a 40 pin IC. Of those 40 pins, you will be having 4 ports, each port of 8 bits. So 4 8s are 32, and the rest 8 bits. One is used for reset, and another one is for ground and VCC. Other than that, we'll be having external access pin, address latch enable, and PSEN, program store enable, and for the crystal oscillator, for synchronizing, giving the clock. So giving the clock, you will be using the pin 18 and 19. So the rest 8 pin is used like that. Each pin we will see it in detail. Okay. So before going ahead with the program status register, let me describe what is the memory of 8051. So memory is of two types. What are all the two types of memory we have? One is ROM and another one is RAM. Right. So when we have an internal memory, in the chip, that is said to be microcontroller. Whereas in microprocessor, we will be connecting external memory. Microprocessor we will be having only CPU, whereas in microcontroller you will be having memory you have RAM and ROM. Okay. So first let us go ahead with the RAM. So RAM, 128 bytes of RAM we will be having. Okay, 128 bytes of RAM. So this is in decimal. 128 bytes of decimal. If I need to convert this into hex, okay, in your calculator, I don't know how many of you is having 991 and ES or MS, whatever you have, in the mode. Okay, switch on it. In the mode you have for base, you have a base N, that is number 4. So if you press it, you have decimal as well as hexadecimal, binary, everything. That I'll tell you one by one. So 128 decimal, okay, 128 decimal, convert that into hex. So if you convert that is nothing but 80. Okay, 80H. So for RAM we will be using 8-bit addressing. So now how to start with this is, so the RAM will start from 00 to 7F, because totally of 128 it is 80. Okay, we will start from 00. We will start from 00H to 7FH. This is 80 actually. 00H to 7FH. This is the 128 bytes of RAM. Of which from 00, okay, 00, 01, 02, 03, 04, like that we will be having 4 register banks. Okay, now we will be having 4 register banks in your internal memory, starting from 00 to 07. Okay, 00, 01, 02, 03, 04, 05, 06, 07. So, and assume the memory as pages of a notebook. Assume the memory as a pages of a notebook. Assume that the first page you will be having n number of lines. Assume it as a ruled notebook. So you have a number of lines, right? Like this. This is the memory actually. So from 00 to each line, this is 01, 00, 01, 02, 03, 4, 5, 6, 7. Okay. This entirely, these 8 lines forms register bank 0. Okay. Forms register bank 0. Each register bank will be having 8 registers. Each register bank will be having 8 registers. Likewise, in 8051, okay, in the RAM, we have 4 register banks. Okay, we have 4 register bank. Each register bank is having 8 registers. So 4 into 8 register, we have totally 32 register. Keep in mind, this RAM is addressed by 8 bits. If I am telling 0 0, this is nothing but 0 0 0 0 0 0 0 0. Okay, this is in hexadecimal. And 0 1 0 0 0 0 0 0 1. This you know because you have read digital 0 0 0 0 and 0 0 1 0 is 2, and 3 is 0 0 0 0 0 0 1 1 is 3. Likewise, we can go on and on. Totally, we have 4 register banks starting from R0, R1, R2 and R3. 4 register banks. Each register bank in turn is having 8 registers. 8 registers. Okay. So, in the lower portion of the RAM memory, we have 32 registers. 32 registers meaning 32 lines of the lower portion of the RAM memory is used as the register bank. So, if I am telling memory, okay, this is RAM memory, 128 bytes of RAM memory. So, first is register bank 0, next is register bank 1, the next one is register bank 2, the next one is register bank 3. Keep in mind, each register bank in turn has 8 registers. 8 registers for R0, 0 0 to 0 7. So, R0, 0 0 to 0 7. Each line of the memory can store 8 bits, meaning a byte. Each line of the memory can store 8 bits, otherwise said to be a byte. Okay, each line can store 8 bits. Then 0 7, keep in mind this 0 7 0 0 to 0 7 is for register bank 0. Then register bank 1 will start with 0 8 because 0 7 plus 1, right? 0 8, okay, 0 8, 0 9, right? Hexadecimal, it can go only up to, what is that, 0 9. After 0 9 you need to write it as 10 is A, 0 A, please wait. Yeah, so 0 8, 0 9, this is all hexadecimal. The addressing will be done in hexadecimal number. So 0 8, 0 9, 0 A, 0 B, 0 C, 0 D, Okay, 1 2 3 4 5 6 0E, okay, 0E and 0F and 0F, right. So register bank R1 starts from 08 and it will end with 0FH totally. As I said already, each register bank is having 8 register. 8 register in the sense each register bank is having 8 lines. Each line can store a byte. You getting me? Right. So R1 is nothing but 08 to 0FH. And then again register bank R2 0F plus 1. What is 0F plus 1? I'm sorry. Yeah. So the next line is 0F plus 1, right? So 0F, how will I write 0F? 0F is nothing but 0 0 0 0 1 1 1 1. In that I have to add one more line, right? 0 0 0 0 0 0 0 1. How will I write? 1 1 0, again 1 1 0 0 0 1 triple 0. It is nothing but 1 0 H. So this will start from 1 0 H, right? Again 1 1 H, 1 2 H, 1 3, 1 4, 1 5, 1 6, 1 7. So register bank R2 starts from 10 H and ends with 17 H. Okay, and register bank 3. Now register bank 3 has to start with 1 7 plus 1, right? So what is 1 7? 1 7 is 0 0 0 1 and 0 1 1 1 plus 1. This is 0 0 0 1, right? 0 0 0 1, right or not? So this is 0 0 0 1 1 is 1 and 1 followed by triple 0 is 8. So 1 8 1 9, okay, 1A, it is not 2 0, that is in decimal, this is hexadecimal. 1B, 1C, 1D, 1E and 1F. Put together this is 8 lines in memory. Each line is a register. This is a register, okay. This is a register. In R3 register you have 8 register starting from R0, R1, R2, R3, R4, R5, R6, R7. Having the address, the register of R0 is 18, address of R1 is 19, 1A, and it goes on and on to 1F. Okay, keep in mind this is the subcomponent of your register bank R3. Likewise, we have 4 register banks. This register R3, this register R3 the address range of R3 is from 18 to 1F. Okay, that is what here it is mentioned. Look here, from 0 0 to, okay, 1F. This is register banks, namely register bank 0, register bank 1, register bank 2 and register bank 3. Okay, okay, 0 1 2 and 3. This is of 8 registers, right. So now after this is this register banks. is of 32 bytes. As I said already, each line can store a byte. Each bank is having 8 registers. We have 4 registers. So 32, 4 register banks. We have 32 registers. Each register can store a byte. So totally 32 bytes. So totally 32 bytes. And now, okay. And now the next 16 bytes. The next 16 bytes starting from 20 to 2F. Starting from 20 to 2F. Okay. Starting from 20 to 2F. The next 32 bytes is used as bit addressable location. It is used as bit addressable location. Let me tell what is that. So after this 1F plus 1, okay, this 1F plus 1, so what is 1F? 1F is nothing but 0, 0, 0, 1 and F is 1, 1, 1, 1. 1F plus 1 is nothing but the next line, 0, 0, 0, 1. It is nothing but 0, 0, 0, 0. And 1 plus 1 is 0, 1, 0, 0. This is nothing but 20H. So the next line of the memory is 20H. So this starting from 20 H to the next 16 byte. The next 16 byte 2FH. Okay, 2FH. The next 16 byte is used as bit addressable memory location. What is the meaning of bit addressable memory location? State for example the line 20 in the memory, it's a single line. Each line of the memory can store 8 bits, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so 20H can store 8 bits. Otherwise, in other words, we can say each line of the memory can store a byte or 8 bits. Am I right? So we'll be having 8 bits, 0, 1, 2, 3, 4, 5, 6, 7, 0 to 7. So totally 8 bits. Each bit of the line 20 can be individually accessed. Okay, it can be individually accessed, and each bit is given an address. If you can able to access those individual registers, each bit, see here, 0, 0 to 0, 7. So here, so bit 20H, the line 20H, this is 0, 0. The address of this bit is 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, like that. If I am telling move 20H comma hash data 05, data will be represented by a hash symbol. Data will be represented by a number, direct number will be represented by an hash symbol. If I am telling move 20H comma hash 05H, in the entire line, what is 05H? 05H is nothing but 0, 0, 0, 0, 0, 1, 0, 1. So the entire line 20H will be saved with 0, 0, 0, 0, 0, 1, 0, 1. Okay, and each of this bit, the address of this bit is 0, 0. Address of this bit is 0, 0. In the line 20H, 0, 0. If I need to access what is there in 00H of 20, I can easily access. but that is not the case in case of register banks R02, R4. You can access as a byte only, okay. For example, here R3 register in 18th line, if I need to read the data in the 18th line of the memory, I can read as such 8-bit or a byte. I cannot read a bit, but in the bit addressable memory location starting from 20 to 22FH, since this is being individually addressed, and you can individually access the bits. Keep in mind, you can individually access the bits, whereas in other parts of the memory location, you have to access as a byte only. You cannot access a bit. That is possible only in the bit addressable location. Each bit of the memory starting from 20 to 2FH is given an address. By using those address, those individual bits that we are storing can be accessed. Okay. So this is said to be bit addressable memory of RAM. From 20 to 2FH. And what is the next line after this 2F? It is 30, right? So from 30 till 7FH. Okay. 30 and 7FH. This is your general purpose area of RAM. Okay, this is your general purpose area of RAM. Now I will show the diagram. Now I think this makes sense. It will be clear for you. From 00 to 1F, 4 register banks. Each register bank is having 8 registers. Register bank 0 to register bank 7. R0 to R7 for register bank 1, again R0 to R7 for register bank 1, for register bank 0, register bank 1, register bank 2, register bank 3. Since I am telling it as a bank of 8 registers starting from R0 to R7, and from 20 to 2F individually each bit is addressed from 00 to 7F here, 00 to 7F here. The next is 16 bytes. This is 16 byte. Okay, 16 into 8, so you will be having that many memory locations, because each line is having 8-bit or a byte. Okay, this portion is bit addressable portion. Each individual bit you can address, you can move, you can change, whatever. Okay, so the rest 30 to 7FH is the general purpose RAM. Okay, right. So this is about the internal RAM structure of your memory. This is your internal RAM structure of the memory. And one more thing what I need to tell you is the stack and the stack pointer. So the internal RAM, it is the general purpose RAM. You can use this the entire portion of the RAM as a stack, Stack is the scratch pad memory or the temporary usage memory that will be using this internal portion of the RAM memory, And if I'm using a part of the memory, for example, I can use I am using anywhere between 730 to 7F, maybe from 31 if I need to use is it as a stack. Okay, from 31 to 7F if I am using it as a stack, I need to mention that from this portion to the user has to define that this portion of the internal RAM memory is going to be used as a stack from 31 to 7FH. Okay, so for pointing out your stack, the stack memory, okay, you will be using a stack pointer register, which is nothing but an 8-bit register, stack pointer register. So I am an user, I am going to use the memory 31H to 7FH, for example, as the stack portion of the memory. That is a temporary memory, you know that, as the stack portion of the memory. Okay, so what I need to do is there is a register called stack pointer register, which is an 8-bit register. It is used for pointing out the stack memory. Okay, it's an 8-bit register. It is used for pointing out the stack memory. So what I need to do in the stack point register, I need to move this 31H, because I need to tell the microcontroller that from 31 to 7FH, it is by default. From 31H I am going to use it as a stack. I am going to use it as a stack. So I need to move the stack pointer register. I need to move the stack pointer register 31H. This 31H has to be moved in the stack pointer register. The stack pointer register is used for pointing out the stack. Okay. And upon reset, if you are resetting your 8051 or when you start your 8051, upon reset, your stack pointer will hold the value of, upon reset, your stack pointer will be holding the value of 07H. What is this 07H line? This is the address. What is 07H in the internal RAM? 07H is nothing but the 8th register of register bank 0. See, 00 to 07. 00 to 07. Upon reset, the stack pointer register will be pointing out this address only, 07. And if I need to use the 31H to 7FH, I need to move the 31H to the stack pointer register. That I will do by coding. Okay. So this is about the internal portion, 128 bytes of RAM. This is about the 128 bytes of RAM. And see, if I need to store in the stack. Okay, if I need to store the data in the stack, namely again I will take it as need to save 3FH in the stack. Now already I have moved stack pointer register to what value I need to move, 31H, because as a user I am defining it as from 31 I am going to use it for the stack. So now your stack pointer is 31H. Okay. So now this is going to be pointed out a stack pointer. Now it points 31H. Okay. So when I need to move this 3FH in 31H, what this stack pointer will be doing is, okay, first the stack pointer will be automatically incremented. I will be using push instruction. Push 3FH, meaning, what is the meaning of this instruction is, okay, this 31H will be automatically incremented first, 31 to 32H. Now your stack pointer register will be pointing 32H, meaning 32 address line. In that, push 3FH will be moved to 32. Okay. The stack pointer, if I use push instruction, the stack pointer register will be incremented by 1. Then the data will be saved in the corresponding line of memory. What is the data? That is 3F. Okay. Similarly, when I need to retrieve the data 3FH, okay, retrieve the data 3FH by using pop. Okay. You can retrieve. What it will do is, first retrieve the data 3FH automatically. 3FH will be retrieved, 3FH will be retrieved, and then this will be decremented to 31. First retrieve and then decrement the data pointer, stack pointer value. Okay, that while during programming I will just tell you. Okay, right. And 8051, in 8051, which does not use this internal 128 byte RAM address from 00 to 7FH, certain operations that do not use 00H to 7FH, which is nothing but 128 bytes of RAM. that is said to be 128 bytes of RAM, that is said to be special function registers used for specific purpose. Those are special function registers or special internal registers. Okay, special function registers or special internal register will be having an address range of 80H2, that is present internally, to FFH. 80H to FFH. This is another 128 bytes. Another 128 bytes. See here. From 80, this is the address, left hand side is 80 to FFH, the next 128 bytes. This is used for special purposes. It is not a part of RAM. This is not a part of RAM. This is not a part of internal RAM. This is special function register starting from the address 80H to FFH. What is that 80H to FFH special function register? See, you have many registers. We have 4 ports, P0, P1, P2, P3 in 8051. P0, port 0 is 80. P1, P2, P3. And accumulator register, program status word register, B register. For serial communication, you have 2 things, serial buffer, serial control register. And for timer register, as I said, it's a 16-bit register. We have 2 timers, T0 and T1. So lower 8 byte TL0, TL1, and higher byte of 0 and higher byte of 1. And for this timer mod register, timer controller register, power control register, PCON, power control register. Is that fine? Data pointer is a 16-bit register again. So DPH and DPL. Stack pointer register, it's an 8-bit register. Keep in mind, each of these registers are stored from 80 to FF. They are not going to use any these internal 128 RAM location. Keep that in mind. Much like this special function registers are addressed in the similar way as like the internal RAM from 80 to FFH. They are not present in the internal RAM, that is 128 bytes. They are addressed like the RAM, that is separate location. 80 to 7FH, that is separate locations. Okay. So see, the P0 is nothing but your port, input output port is having the address 80H. Either I can say P0 or I can say even 80H. Both are pointing out only the P0 register. Sorry, P0 port. You are getting me what I am telling? Yeah. So now you have these these registers, special function registers, address ranging from 80 to FFH. Okay. Now let me tell about program status register. So program status register, it is PSW. It is being stored. It is being here in special function register. PSW is D0. It is in the address D0. Program status register, it is in the address D0. It is an 8-bit register. It reflects the status of the program. Right. So this one, okay, this is PSW 0. See, PSW.0. This is also bit addressable, meaning each bit of the program status register can be accessed you can easily access. This P bit is said to be parity bit. This P bit is said to be parity bit. It will be 1 or 0. Okay, it will be 1 or 0 based on the instruction or the result of the instruction. Okay, to indicate an odd or even number of ones in the accumulator. Usually this is odd parity. For example, if I am adding two numbers, if the result is having odd number of ones, then this parity bit will be set to 1. Okay, and this PSW.1, this bit is a user defined bit. This is overflow flag. This is used for selecting the register bank. We have register banks 0, 1, 2, 3. If the bit is 0, 0, that is register bank 0. This is the default register bank. If I am not mentioning anything, by default register bank 0 will be selected for operations. 0, 1 means register bank 1, 1, 0 means register bank 2, and 1, 1 means register bank 3. This is used for selecting your register. And F0, this is also, it is available for the user for the general purpose, and this is for auxiliary carry, and this is for carry. Okay, this is for auxiliary carry and that is for carry. This is said to be your program status register. It's an 8-bit register. It reflects the status of the operation, arithmetic operation or any other operation that the CPU is doing. Okay, while we are dealing with the instruction set, I'll tell you how this is going to be reflected. With this, I'll stop today. Okay, I have dealt with the memory, the special function register and the program status register today. Thank you.